All right, welcome back. So we're going to try example number 4. We're asked to find how much money needs to be deposited now in the account to obtain $6,100 in the future after 10 years if we invested in it with an interest rate of 6% per year compounded continuously. Round your answer to 2 decimal places. So I'm going to highlight the most important part of this problem is that it's compounded continuously, right? Since it's compounded continuously, we know that we're going to be using this formula. All right, so so obviously we need to know what is A, what is P, what is R, and what is T, right? A is always a future value, and in fact, that's why we are dealing with this problem, because they're asking us how much do we need right now to deposit. That means your initial amount, so that in the future, right, the final amount is 6,100. So what they're asking us here is to let the final amount be 6,100 and find out how much is your initial investment, which is your P. Where the rate is 6%, but remember when we use this formula, we need to write this in terms of decimal. So it'll be 0.06. And then your T is the number of years. So T is number of years. And so now once we plug it into the equation, into the formula, so it'll be 1,600 times P times E to the 0.06 times 10. And we can multiply those two, right? 0.06 times 10 is 0.6. All right, so we know that this is a multiplication. So if we're solving for P, then we can simply just divide both sides by 0.6, right? Because remember that this is 0.6. So these will cancel each other out, and this will leave us with P is equal to 1,600 all over E to the 0.6. And this is actually not so hard to put in a calculator, so we're going to try that. And so we're going to do 1,600 divided by E. So E, let me solve over again. So 1,600 divided by, and E, if you notice, is by the ln. If you notice above the ln, you will see an EX. So we're going to go second, and then ln, which gives us EX, and then automatically it allows to input the exponent, so it'll be 0.6. Enter. And that is 3,347.75. 0, right? And let's go ahead and round it to the nearest cent. So it'll be $3,347.75. So we need to invest this much money so that when we invest this at 6% per year compounding continuously, we will have $1,600